Hello, and welcome to another edition of Math in the Kitchen with Miss Stewart. Hi, everyone, and welcome to another edition of Math in the Kitchen. Today, we're going to be talking about a really special topic that is going to play into several more episodes, and that is the idea of converting mixed numbers into improper fractions. And so what that means is that we're going to take that nice, complete answer that we usually get, and then we're going to work it into an improper fraction where the numerator is bigger than the denominator. Because when we're giving answers, sometimes it's really nice to see that whole number with a fraction. It looks nice, neat, and simplified. But on the occasion, when we're working out math problems, we actually need an improper fraction to make the problem a little bit easier to solve. So let's review what those terms mean. Let's remember a mixed number is when you have a whole number with a fraction. So for example, the number 3 7/8 is a mixed number because we have a whole number along with a fraction. Now, when we turn this number into an improper fraction, that's when the numerator becomes larger than the denominator. So 3 7/8 becomes 31/8. Now, you may be asking, Stuart, how did you get there? What does that mean? Why would we do that? Well, let me show you. Let's take, for example, 1 1/2, okay? 1 1/2. If I use just the traditional breakdown method, here's what 1 1/2 means. I know that anytime we have a number over itself, like 8/8, that's gonna equal 1 whole. Just like if we had maybe 16/8, that's gonna equal 2 wholes, okay? So we're discussing this idea of, in this problem, what does 1 whole mean for this problem? And in this case, 1 whole is also equal to 2/2, okay? Because anything over top of itself is equal to 1 whole. So 1,000,000/1,000,000 is only 1 whole. Or 1,000,000,000/1,000,000 is only 1 whole. So in this case, 1 whole equals 2/2. Now the reason why I picked the number 2 is because this fraction right here has a denominator of 2. So in order for this problem to work together, my whole number needs to be in halves or in 2s, okay? So 1 whole is 2/2 or 2 halves, but don't forget that this problem also has this piece here, 1/2. So I'm going to put it together. 2/2 plus 1/2 equals 2 plus 1 is 3. And then remember, when we're adding, we're not changing the denominator. We're going to keep the denominator the same. So it equals 3/2. And that's how I was able to turn my mixed number of 1 1/2 into an improper fraction of 3 halves. Okay? Let's take a look when the whole number isn't just a 1. Now I have an example too. My whole number is a 3. What does that mean? How do we change that into the right number or the right fractions that we need? Well, I'm taking a look here and I'm seeing that this fraction right here has a denominator of 4. So that means if I break down 3, there's 3 holes here. 1, 2, 3. Each one of those holes is going to be 4 fourths, 4 fourths, and 4 fourths. So when I add them together, I get 12 fourths. And if you think about it, 12 divided by 4 is 3. Remember, fractions are another way to represent division. So this is working. This is exactly what this is supposed to mean. But don't forget, in this particular problem, we also had a fractional piece, a piece that didn't quite make it to 1 whole. We still have 3/4 left. So we're also going to add that guy on too. So now when I add the whole thing together, when I change 3 3/4 to an improper fraction, I'm going to get 4 plus 4 plus 4 is 12 plus 3 more is 15, I'm going to get an answer of 15/4. Okay? So this is how we do the conversion from a mixed number to an improper fraction when we're breaking it down based on the wholes that we know. But there's, I don't want to say simpler method, but there is a more streamlined method of solving this problem going from mixed numbers to improper fraction. And it's what I refer to as the C method. I don't know the technical name, if there even is a technical name, but I call it the C method. And what that means is we're going to take and do 2 steps with our mixed number. I'm going to have a whole with a fraction piece. Okay, and I just used A, B, and C right now to represent what I'm talking about because these could be any numbers. So in my mixed number, I'm going to use the C method and I'm going to start here at the denominator and I'm going to circle around. This is the format that I take. Start at the bottom, circle around. And so what I'm going to do is take the denominator times the whole number and then add on the leftover numerator. Now, if you think about it up here, that's exactly what I did. I had repeated addition, which remember from our previous lesson, repeated addition is multiplication, plus the leftover piece. That's exactly what I'm doing here on the C method, except I'm not using repeated addition. I'm jumping straight to multiplication. Denominator times the whole plus the leftover gives me my new numerator, and then my denominator stays the same, just like on the last piece. So let's take a look at these examples that we've already done, but now let's use the C method, okay? So if I have 1 1/2, and I want to turn that into or convert it into a mixed number, I'm going to use my C method. Start at the denominator, circle round, times, and add. And I would do this every single time. I have been doing these kinds of problems for over 20 years, and I always write my symbols because it keeps me organized and it keeps my mind and my eyes and my hand on the same page. Okay, so let me start in the right spot. 2 times this 1 is 2, plus 1 more is 3, so the numerator now becomes 3, and I keep the denominator, which is 2. And so with the C method, we were able to get the exact same answer, 3/2. So as you can see, this method is a little bit more streamlined. You get to do all of the processes in one motion, okay? Let's take a look at the next example. We had 3 3/4, okay? Same process here. The C method, start at the denominator, circle around to the numerator, times it, and then add that part up there. Start here. 4 times 3 is 12, plus 3 more is 15. So my numerator is 15, and the rule is keep the denominator the same. And so we get an answer of 15/4. So now you've seen 2 ways to turn a mixed number into an improper fraction. It's up to you to decide which method you like the best. I think for time and for organizational purposes, my favorite method is the C method. It just kind of flows and makes sense to me. But you use what makes sense to you. If it makes sense to you to write out your whole number as 4/4 plus 4/4 plus 4/4, go ahead and do that. What we want is accurate answers. It doesn't matter how you get there. All right, let's take a moment now to have you guys solve a problem on your own, okay? Here's the problem that I'd like you to solve. 5 6/7, okay? 5 6/7. I want you to take a moment, pause the video, grab a sheet of paper, get a pencil, and let's solve this problem. Let's do both ways. Maybe you can make a little chart too and call the top one the breakdown, call the bottom the C method, kind of like I have over here, and solve your problem and see if you get the same answer twice. All right, and now that we're back, let's go ahead and solve this problem. Let's see if we all came up with the same answer. So on the breakdown method, I'm going to break this 5 wholes into those fractions that are wholes, and I need 5 of them. Okay, so 1, 2, 3, 4, 5. So I know my denominator is 7, so I'm going to be using sevenths. 7 sevenths plus 7 sevenths plus 7 sevenths plus 7 sevenths plus 7 sevenths. Now let me be accurate and make sure that I only have 5 of those. 1, 2, 3, 4, 5. I'm good. Now I'm going to not forget this piece up here, this 6 sevenths, because remember that didn't quite make it to a whole, so we can't make it a 7 sevenths. It has to remain 6 sevenths. And now let's see what we get. All right. So I see here repeated addition. So in my head, I'm going to group this together and multiply. 1, 2, 3, 4, 5 sevens is 35, plus another 6. Do whatever you have to do to get there. 35 plus 5 more would be 40, plus an extra 1 is 41. So I'm getting 41 sevenths, okay? Now, let's take a look at what this problem looks like using the C method. 5 and 6 sevenths using the C method. I start at the denominator, I circle around to the numerator, times and add. 7 times 5 is 35, plus 6 more is 41, and I keep the denominator the same, 41 sevenths. Now, boys and girls, go back to this problem in this video as many times as you need to, because this strategy right here is going to help propel you into the next several lessons in math. So enjoy this lesson, watch it, use it, do it, comment, like, share, whatever you need to do. Thank you so much for watching Math in the Kitchen. We'll see you next time.